projections of points when a point is placed in third and fourth quadrant. Okay, we can start with an example problem. A point, maybe its name C, is 30 mm below HP and 35 mm in front of VP. Draw its projections. Any prediction regarding the location of the point? I just written a question in the board. For your convenience, I am reading out. A point C is 30 mm below the horizontal plane and 35 mm in front of the vertical plane. So from this statement, any prediction regarding the location of the point, in which quadrant the point is actually placed now? First, second, third or fourth? In which quadrant? It is in fourth quadrant. The point is in now fourth quadrant. See, the point is below HP and in front of VP. Below HP and in front of VP. Once you consider the environment, diagram. So it's your first quadrant, second, third and fourth quadrants. The current point C is located below the horizontal plane and in front of the vertical plane. Okay, below the horizontal plane and in front of the vertical plane. So the only choice is the fourth quadrant. How much below the horizontal plane? 30 mm below the horizontal plane. 30 mm below the horizontal plane. Okay. And 35 mm in front of the vertical plane. In front of the vertical plane, 35 mm. It is 35. So exactly the point is located here. The point is 30 mm below the horizontal plane and 35 mm in front of the vertical plane. Here the point is located. For your convenience, I am marking it with a little bigger size. The point is capital C. Now our duty is to draw the front and top views. Already we discussed a lot about how the front and top views of the point is developed when you project it by means of the horizontal plane and vertical plane concept. So without wasting the time, let me go for the environment in the paper. First you need to draw the XY line. The XY line first you have to draw, and here the point C's front view will obtain in the vertical plane here as C dash, and the top view of the point, some serious measure you have to consider here. It's your new situation. The point is located below the horizontal plane. In order to obtain the top view of the point, you have to see the point from the top. That is, your visual rays are perpendicular to the horizontal plane. And in the previous case, when the point is located above HP, maybe in the first quadrant or the second quadrant, like the shadow, the top view of the point is fall on the horizontal plane. Now the point is located below the horizontal plane. However, the only hope for the view to be deposited is only on the horizontal plane. So you have to move the top view towards the horizontal plane. And here we loaded it. See, this is nothing but the top view of the point C. Top view of the C, which is obtained in the horizontal plane. Front view of the point C dash, which is obtained in the vertical plane. And then, in order to make it in the paper, we need to rotate the horizontal plane in clockwise direction about 90 degree. It's our usual procedure. Clockwise direction and 90 degree. Before that, first let me to complete the front view of the point. the front view of the point is nothing but the C dash. C dash need to be drawn with respect to the XY line. Here the C dash and the C are with location can be given with respect to the horizontal plane and vertical plane. But in our paper, we needed to draw it with respect to the XY line. So just to find out where is the XY line. XY line is here. The line which is obtained by the intersection of the horizontal plane and vertical plane is nothing but the XY line, your reference line. With respect to this XY reference line, where the point C dash is located, below or above XY? It is actually below the XY line. This is XY line, this is your C dash, the front view of the point, located below the XY line. How much below? 30 mm below. So with respect to the XY line, below 30 mm, I need to mark the front view of the point C dash. So roughly I am making it here. It is C dash. Immediately after marking the point and naming it, we have to draw the projector. It is our usual procedure. So I am drawing a projector from C dash towards the top view, front view area. Since the point is located below the horizontal plane, the front view is now obtained below the XY line. But in the previous two problems, the front view always located above the XY line in the answer. That's because of the actual location of the point. In the previous two problems, the point is located above the horizontal plane. So by nature, the front view obtained is become above XY line. Now the point is located below the horizontal plane. It is in the fourth quadrant. So automatically the front view will be obtained below XY only. And then now think about the top view. The top view, point C is now in the horizontal plane. In order to get it in the 2D plane, we have to rotate the horizontal plane in clockwise direction about 90 degree. If I rotate like that, the top view will be obtained here. It is nothing but your C dash. Again the top view comes below the XY line, not above the XY line, comes below the XY line. And how much below XY line? I am asking what is the distance between the top view C and the XY. What is this actually? See here, yes, it is 35 mm because the point is already 35 mm in front of the VP. So the same distance is maintained here also, which is nothing but the radius of the rotating circle. So when you rotate this horizontal plane with respect to clockwise direction, so the same 35 mm will be maintained here also. So in order to mark the top view of the point here, you have to measure 35 mm below the XY line and mark it in the projector of C dash. I measured 35 mm below XY, and in the projector of C dash, I can mark the top view of the point C. This is nothing but the answer to this question. Okay, we just drawn the front and top views of the point which is located in the fourth quadrant. The projection methodology is the same which we followed in the for the previous two problems. The quadrant of the point only varies. In the two previous problems, we worked with the first quadrant and second quadrant. Now it is actually fourth quadrant. Okay, and let me draw above the board, and we will practice how to draw the front and top views of the point when it is located in the third quadrant. The point G is 40 mm below HP and 30 mm behind VP. So just by analyzing the location with respect to the horizontal plane and vertical plane, you can finalize in which quadrant the point is actually processed. See, it is in third quadrant, below HP, behind VP. It is in third quadrant, not in first, second and fourth. Right. How much below? 40 mm below. below. And how much behind VP? 30 mm behind VP. The point may be here. You're supposed to draw the front and top views of the point. The front view of the point will be obtained in the vertical plane here as is actually G, and here we can have G dash, and the top view will be obtained in the horizontal plane as small letter G. Okay, G dash and G are the front and top views of the point. Okay, now you can draw the same in the paper. This is your XY line. Before going to the paper, just we made the top view with rotating the horizontal plane up to 90 degree in clockwise direction. If you rotate your horizontal plane up to 90 degree in clockwise direction, what will happen? Along with the top view G, it will rotate and it will be located here. Now the location of the top view comes above the XY line. It is your top view G. And how much above? Any idea? What is the distance of this top view G and the horizontal plane?
30 mm.
How much?
30 mm.
30 mm. Very good. The same 30 mm is maintained here also. Again the same will be maintained if you rotate it here. So this is 30 mm. Now we are going to draw this G dash and G in the paper, not with respect to HP VP, with respect to XY we are going to draw. For that, first we have to draw the XY line. And then starting from the front view, where actually the front view is, here it is G dash, it is below XY or above XY? Below XY, below XY. How much below XY? 40 mm below XY. Okay, 40 mm below XY. So from XY line, we are measuring 40 mm. And I am marking a point G dash here. G dash here. Immediately I am drawing the projector line towards the front view area. And the point G, small letter G, is nothing but the top view here. Top view here. Where it is located with respect to XY? With respect to XY, it is above XY. It is above XY. How much above XY? 30 mm above XY. So 30 mm above XY, we have to mark the top view of the point. In the projector of G dash. That's very important. You should not mark the top view in somewhere else. Strictly your front and top view should be connected with a projector line which is perpendicular to the XY line. Okay, the projector line should be perpendicular to the XY line. In any question for the projector of any point, if it is said to be a projector, it should be perpendicular to the XY line, and your front and top views should be lies in the same projector. Okay, G dash and G. So this is nothing but the answer for this question. So within that question, we can finish up the regular discussion on projection of points. Let me to give some special kind of questions here, which are all little confusing yourself in the projection of points. Maybe we can see two more questions in the projection of points. There is no difference in the concept, but the question is somewhat different when compared with these open questions. You may write it if need. A point D is 40 mm in front of VP and in HP. Draw its projections. This is nothing but the question. A point, its name is D, is located 40 mm in front of the vertical plane, and the point is just in the horizontal plane. There is no distance maintained between the point and the horizontal plane. The point is not above HP or below HP. It is in HP. So how the point will be like that actually? This is nothing but the point. The point name is D. It is 40 mm in front of VP and in HP. 0 above HP or 0 below HP, that way. Okay, any idea about the quadrant of the point? In which quadrant the point is actually here? First, second, third, fourth. In which quadrant it is here? If it is said to be in first quadrant, the distance, the location of the point should be above HP and in front of VP. If it is said to be in the fourth quadrant, the statement should be it below HP and in front of VP. Now it is not above or below HP, it is in HP but in front of VP. So the competition is between first quadrant and fourth quadrant. Actually this point is exist in which quadrant?
I think it's a line, sir.
Yes?
I think it's a line. Both the quadrants.
It's in this problem we are not able to say the exact location of the point with respect to any specific quadrant. Okay, there is no specific answer for this question, but we can draw the front end of views of the point, that's different, but it is not possible to give the exact name of the quadrant in which the point is lies. It is not in first quadrant and not in fourth quadrant. Here the point is there in the middle of the two quadrants, maybe in the border. So here, so where you can get the front view, if you see the point from the front, where you can get the front view? Here you can get the front view as D dash. And where you can get the top view? Here the top view will be obtained first. After rotating the horizontal plane as usual, the top view will be obtained here finally. So this is nothing but the D. So with this you can draw the D dash and D. If you supposed to draw the D dash and D here, see with a rough manner I am drawing it without proper tooling. The front view D dash will be obtained in the XY line itself. XY line itself, because if the point is having any distance with respect to the horizontal plane above 1 mm or above 10 mm, then we can maintain with respect to XY here also above 10 mm we can maintain, but here 0 above the horizontal plane the point is located. So as usual we need to maintain the same distance in there also. The point front view can be located in the XY line itself as D dash. Immediately after that you can draw the projector, and then the D, it's very easy to locate the D. It is below XY. How much below? The same 40 mm below XY. So below XY we can measure 40 mm distance, and in the projector of D dash you can mark the top view of the point D. top view of the point D. In this way you can draw the front and top views. Here also the concept of projection and drawing the same in the paper are same. The initial location of the point only differs. In the same way we can have some conflicting questions. See, if it is a point, how to write the question for that point? The point E is in VP and maybe 40 to 50 mm above the HP. We can write a question like that, and you can write a question for this point, and you can write the question for that point also. So in that way I will give you projection. You can write the answer for you can write the question for that. Okay, and you can easily draw the front and top views for that also if the point is located in these kinds. And one more special case is that if a point is in HP and VP, how to draw it? The point is in HP and VP. How to draw it? Where the point will be actually located? In this way you can locate the point. The point is in HP and VP. Is nothing but the point is in the reference line. If you try to draw the front and top views of the point will be obtained in the same place. In the same place, in the XY itself. There we can mark the front view and the top view. A dash comma A, both in a same point. If the point is in both HP and VP. Then in the reference line itself, without taking any distance and all these things, you can mark the front and top views of the point in a single location. So in that way we can have some typical different type of questions in the projection of points chapter also.